Welcome to the Explainer. Today, we're diving into something that is literally reshaping how we build and test hardware, the AI revolution in embedded systems. Look, if you've ever dealt with microcontrollers, hardware-in-the-loop setups, or those massively complex validation pipelines, you already know the pain of repetitive, manual testing, right? It's a grind. Well, let's explore exactly how artificial intelligence is stepping in to change all of that. So here's the core thesis we're uncovering today, and it's simple but incredibly powerful. AI accelerates debugging and reduces repetitive tasks. Now, despite all the noise out there about AI coming for our jobs, in embedded engineering, it's actually acting as an amplifier. It takes all that heavy lifting out of validation workflows, completely freeing you up to actually engineer brilliant solutions instead of just wrestling with scripts. Okay, let's dive into this. We've got a great roadmap for today. First up, the AI engineering shift. Number 2, transforming HIL and validation. Third, the embedded AI toolkit. Fourth, a real-world workflow. And finally, future-proofing your career. All right, part 1, the AI engineering shift, focusing on accelerating validation and automation. When we look at the immediate day-to-day impacts of AI, requirement analysis and traceability really stand out. Picture this. You're staring down a 500-page specification document, trying to manually map every single requirement to your test cases. Well, AI can now ingest that entire document, summarize the specs, and trace them directly to your code in a fraction of the time. It's also stepping in for automated test case generation, meaning it can create those tricky edge case tests instantly. And for log analysis and fault detection, AI models are parsing thousands of lines of system logs in literal seconds to pinpoint a fault. Add in code generation and debugging, and suddenly your whole workflow moves to a much higher, much faster level of abstraction.
Moving right along to part 2, transforming HIL and validation. This is where hardware in the loop meets AI.
Now, what's really interesting about this is how AI tackles the classic engineering bottlenecks. Hardware in the loop is the absolute backbone of embedded validation, but let's be honest, it's traditionally a massive time sink. What's fascinating is how AI just bypasses this. Instead of you manually scripting every single voltage drop or sensor failure, AI models generate those test scenarios automatically, based on system parameters. And you know the struggle of staring at oscilloscope captures trying to find a microsecond glitch. Well, AI now analyzes that waveform data and detects anomalies in real-time simulations. Finally, it gathers all that pass-fail data and logs the whole shebang to create automated validation reports. It completely removes the manual reporting bottleneck. Let's shift gears to part 3, the embedded AI toolkit. These are the tools for the modern engineer. If you're looking at your digital workbench right now, a few specific tools are proving to be absolute game changers. First up is Notebook-LM. It is phenomenal for technical knowledge management. You just feed it your datasheets and proprietary docs, and boom, it becomes a customized expert on your specific hardware. Then you've got ChatGPT, which is excellent for rapid debugging and scripting. But say you're working with highly confidential C code that absolutely cannot leave your local network. That's where Ollama comes in. It allows you to run local large language models right on your machine, which guarantees total data privacy. And finally, integrating Python with AI APIs is what stitches all of this into one seamless, highly automated engineering workflow. Let's move to part 4 and see how this builds into something tangible, a real-world workflow from documentation to results. Okay, let's actually see this in action. Imagine you're tasked with validating a brand new power inverter against some incredibly complex grid code regulations. Step 1, you upload that dense grid code documentation right into a tool like Notebook-LM. Step 2, you prompt the AI to summarize the exact testing requirements for you, things like voltage bounds and frequency limits. Step 3, you take those fresh requirements over to ChatGPT or your local LLM to generate the PyTest skeletons for the HIL bench. Step 4, you run those HIL simulations. And finally, Step 5, you have the AI automatically analyze that massive dump of pass-fail results. Seriously, a process that used to take a full week of reading and scripting, you can now architect that in a single afternoon. That is huge. And that brings us to our final section, part 5, future-proofing your career and becoming the engineer of tomorrow. The trajectory of embedded engineering is moving so rapidly toward AI copilots, specifically designed for validation engineers. Honestly, it is wild to imagine an assistant just watching your pipeline and suggesting real-time optimizations. But that is exactly where we're heading. We are also seeing this massive shift toward natural language automation. We're talking literally typing, run a thermal stress test at 85 degrees. and having the system just compile and execute it for you. This is completely paving the way for fully autonomous testing pipelines and AI-assisted model-based development, where the AI handles the repetitive execution, and you, the engineer, get to focus on the high-level architecture. So, what does this all mean for you? Well, combining AI and embedded systems is currently one of the highest demand niches in the entire tech world. There is an incredibly strong opportunity out there, especially in sectors like automotive and power electronics. I mean, just think about the massive validation needs for EV battery management systems right now. Mastering these AI tools differentiates you in interviews, boosts your professional branding, and builds a truly future-proof engineering skill set. Basically, it makes you the person who solves the bottlenecks rather than the one who's stuck executing them. If there's one thing you take away from this explainer, let it be this crucial point. AI is not replacing embedded engineers, it is amplifying them. These tools exist entirely for your empowerment. They give you the speed to eliminate tedious data parsing, allowing you to focus on the creative, complex problem-solving that made you want to become an engineer in the first place. So taking a look at the hardware sitting on your desk right now, the question is, how will you use AI to amplify your next project? Whether it's feeding a datasheet into a local LLM today or writing a quick Python script to automate a single log analysis tomorrow, that first step is ready to be taken. Thanks so much for exploring this with us. Keep innovating, and we'll catch you in the next explainer.